In this lesson, we are going to look at the application of some physics principles in advanced technology such as fiber optics. People say that the world is getting smaller, and that's quite true when you have Internet technology. Internet technology connects friends and loved ones across land and sea. We can talk with each other anywhere, anytime, and in an inexpensive way. Copper cables are still being used in telecommunications, but they are slowly being replaced with a superior transmission medium. What is this new technology that has helped improve communication tremendously? Optical fibers are the new revolutionary transmission medium that will replace copper cables. Let's learn more about these fibers. Optical fibers are fine fibers of glass or plastic only a few microns thick in diameter. While copper cables carry electrical signals, optical fibers carry signals in the form of pulses of light. Wherever the optical fiber bends, the light will also bend and follow the curve of the fiber. This is possible because of the process of total internal reflection. Click and drag on the optical fiber to bend it and see how the light also follows. The optical fiber consists of a core surrounded by a cladding layer. For total internal reflection to occur in the core, the refractive index of the core must be greater than that of the cladding. The critical angle for light traveling from the core towards the cladding is small. This means that the angle of incidence of the light is frequently greater than the critical angle, so that all the light is reflected back into the core. This process of total internal reflection is repeated throughout the whole length of the optical fiber, so that the light is transmitted over long distances many kilometers away. A single pair of optical fiber can carry thousands of such light pulses, and so thousands of people can have two-way conversations at once. What are the advantages and disadvantages of using optical fibers over copper cables? Click on the buttons to find out. Optical fibers have a higher bandwidth than copper cables. That is, they can carry more information. There is also less energy loss than in copper cables, and so they can carry information over longer distances. Optical fibers are much lighter and thinner than copper cables. This also means that they are easier to handle and takes up less space. Optical fibers are more secure than copper cables because they are much more difficult to tap into to steal information. This is a great advantage for banks and security installations. Optical fibers are not affected by electromagnetic interference from radio signals, car ignition systems, electronic equipment, and thunderstorms. This means information sent over the fibers will not be disrupted. Optical fibers do not produce sparks. Therefore, they are safe to use in petrochemical industries. Optical fibers also have high electrical resistance, thereby making it safe to use near high-voltage equipment. Copper system uses far more electrical power than optical fibers. Therefore, optical fibers conserve energy. Although the raw material for making optical fibers is sand, they are still more expensive to make compared to copper cables. However, this is compensated by the fact that one optical fiber can carry much more information than many copper cables. Special expertise is needed in handling optical fibers. For example, optical fibers cannot be joined together as easily as copper cables. What kind of light is used in optical fibers? Lasers are used because they can create very tightly focused pulses of light which doesn't disperse or radiate away, as all the rays travel at the same frequency. If white light were used, the different frequencies of the colors of light would travel and reflect at slightly different speeds within the fiber, and over a long distance the signals would begin to overlap and lead to a distorted image or sound. What are some of the applications of optical fibers? Click on the buttons to find out. Telecommunication is the transmission of data over a distance. An optical fiber of several microns thick, that is thinner than hair, can transmit millions of light pulses per second. The changing intensity of the light ray is used to represent different signals. If an incident light ray that carries a message is directed at an end of an optical fiber, the fiber will transmit the ray to the receiver at the other end. A converter then recovers the original message. Since not much of the light ray is lost in the course of transmission via an optical fiber, the messages can be transmitted over a very long distance without a midway transfer station. The fibers can be easily laid underground and under the sea. This is a great means on transmitting signals over long distances with minimal loss, and it is surprisingly cheap to build, lay, and use. Underwater fiber optic cables currently carry telephone and internet signals across the Atlantic and Pacific Oceans. Optical fibers can be used as sensors to measure changes in strain, temperature, pressure, and concentration. The principle of operation is that the light beam is changed by the phenomenon that is being measured. The light beam may be altered in its intensity, phase, polarization, wavelength, or spectral distribution. These sensors are used in medicine, industry, and robotics. Illumination refers to bringing bright light from a source, often around corners and obstacles, into confined spaces or where it is needed. In some buildings, optical fibers are used to route light for interior illumination, or sunlight may be routed to solar panels to generate solar power. Showcases are also brightly lit using fiber optic lighting. Optical fibers are used, sometimes along with lenses, in a long, thin imaging device called endoscopes. Medical endoscopes are used for viewing organs inside the human body. Industrial endoscopes are used for inspecting hard-to-reach places, such as jet engine interiors. Optical fibers are fibers of glass or plastic that carry signals in the form of pulses of light. The light follows the path of the fiber even around corners, using the principle of total internal reflection. Optical fibers have high bandwidth and there is less energy loss in the transmission. Therefore, they can carry more information over long distances. Optical fibers are used in telecommunications, sensor systems, illumination, and imaging devices.